What's up, guys? Let's have a look at question 3, June exam paper 2. It was an analytical geometry question. It was given as follows in the diagram below. All right, let's read the question together, guys. In the diagram, the equation of AD, therefore this is the equation of this line. It's given by this equation right here, 2y plus x is equals to 11, and therefore we have got m, which is 1 minus negative 1, is the midpoint of a straight line joined by AC. So we see that midpoint right there, and then they give us the coordinates of B, which is AB, and the coordinates of C as well, which is 3 to 4. The angle of inclination of AD and BC is given by theta and beta respectively. There we go. We see that there's beta there, there's theta there, right? And then they said E and F are the y-intercept of AD and BC respectively. Reading the question is very important, guys, so that you fully understand it and then you don't make a mistake while you answering these questions. So now let's have a look at 3.1. 3.1, it says that determine the coordinates of B. Okay, what is B? B is sitting here, and then we have got M and C on the same line, and they did say M, it's a midpoint. So therefore, what we're going to do now, I'm just going to illustrate here for you guys 3.1 so that you fully understand it. This is basically what is happening here. You've got a line like that, and then let's say here you've got your coordinates of C3 is to 4, and then you have got in the middle here you've got a midpoint of 1 is to negative 1, and then therefore here at the end you should have B, which is A and B. Therefore they want us to find that. So if you've got two coordinates, the other one is the midpoint, we can therefore use the midpoint formula. So therefore what we would say that, okay, x at the midpoint, if we're getting the midpoint formula, you can get it by saying x at C plus x at B over 2. Therefore, similar thing, you would do the y at midpoint, it's equals to the y at C plus the y at B all over 2. So therefore, what is the x at midpoint here? The x at midpoint is equals to 1. The x at C is equals to 3. Therefore, plus the x at B, it's A divided by 2. Therefore, you are going to cross multiply here to find the value of A. So 2 times 1. Sorry, guys. Cross multiply 2 times 1 will give us 2. It's equals to 3 plus A. So therefore, in order to get A, you're going to say A, it's equals to 2 minus 3, which gives us negative 1. Similar thing you would do here. Y value at the midpoint is negative 1. It's equals to y at C is equals to 4 plus y at B is going to be given by B all over 2. So cross multiply here. 2 times negative 1 will give us negative 2, which is equals to 4 plus B. Therefore, take 4 to the other side. Therefore, B will be equals to negative 2, negative 4, which gives us the value of negative 6. Therefore, let's check if that makes sense. It does make sense. Wait a minute. Does it? Yes, it does make sense. X is negative here, y is negative on the third quadrant. So therefore, the value of B, the coordinates of B rather, is going to be negative 1, negative 6. Right. So therefore, that's how you would deal with this one. This one, it is also known as midpoint in reverse. All right. So moving right along, 3.2. 3.2 is saying determine the gradient of BC. So let's come here and have a look. BC is here. We just determined the coordinates of B. So basically, the best thing to do here is to use coordinates of C and M to find the gradient of this line here. So this is what we would do. We're going to say, okay, C, coordinates of C is 3, that the coordinate of M, because the M is also on the same line, in case we made a mistake here to calculating the coordinates of B, so then we don't have to worry about that. So now we use what was given to us to make life easy for ourselves. So here in this case, what was given was this 2. So therefore the gradient of the line BC is going to begin by y at C minus y at M all over x at C minus x at M. You're probably asking yourself, okay, what about if you say y1 minus y2, x1 minus y2? Doesn't matter, guys, as long as your substitution is correct, you should get to the same answer. I'm doing it like this because most of my students complain when they say we say x1 and x2, they get confused. So I think it's better to number them according to the letters that are given thereof. So okay, the y at C is equals to 4 minus the y at M, which is -1, all over the x at C is equals to 3 minus the x at M is equals to -1, is going to be given by what? By 5 at the top, 5 minus 2. And that's how you would deal with the gradient of this equation, right? So let's move right along to the next question of 3.3. All right, 3.3, the question says determine the equation of, I think we're going to have to go a little bit back here because we have to remember the equation of this line, because I think we are going to need it. It was given by 2y plus x is equals to 11. Great stuff. The gradient of this line, we did find it, it was 5 over 2, which is the gradient of BC. All right, and then the coordinates of B was given to us by -1, -6. Guys, I'm just putting the information from the previous page here in case we do need them. So they're asking us to calculate the angle theta. Angle theta is this angle right here. Okay, what we would do first, you can see that we've got the angle of inclination here. We also got the angle of inclination here. So now if you are doing analytical geometry, guys, and then they speak about angles, your first thing to think about is angle of inclination. So let's go ahead, and then we found this angle here, which is alpha. All right, so I think that's where we're going to start. Let's come here, 3.3. so let's start there. Okay, what we would do on this equation that is given to us, we are going to say make y the subject to the formula, take x to the other side, and then divide everything by 2. So it's going to be -x here, divide everything by 2, plus 11, divide everything by 2. Basically what I did there, I just made y the subject to the formula. So what is the gradient of this line? The gradient of this line would therefore, gradient of line AD, it's going to give us by being given to us by -1/2. So what do we do if you have a gradient of a negative and you are looking for angle of inclination? You don't include it. So therefore our angle of inclination, it is going to be given by tan alpha, it's equals to half. Therefore we don't put the negative there. We go to our calculator, second function, half, which is 0.5. This thing will give us a value of 26, which is what I'm getting. Guys, please make sure that you get the same answer. If you don't get the same answer, pause this video and double check yourself, or leave a comment on the comment section below. All right, so now what we just did now, we just found this angle here, which is alpha, but this is not the real alpha, guys. This is the reference alpha. Remember, we left the negative out there. So this is the reference angle. Therefore, to find the real alpha, we need to say 180 minus the reference angle, which is 26.6. Therefore, the original angle will therefore be 153. Let me just double check on my calculator. 153.43. So therefore this is this angle right here, 153.43. But guys, you need to remember, when you do Euclidean geometry, there's a rule that says an exterior angle of a triangle is equal to the sum of internal opposite. Okay, so what does this mean? This means on a given triangle, which is this triangle here. In this case, I'm just gonna mark it here with the dots. This triangle here, this is the one I'm referring to. So can you see the exterior angle of this triangle is alpha, and then the internal is this one, and is theta and beta. So therefore, what does that rule say? That rule says exterior angle, which is this one, of a triangle is equal to the sum of internal opposite. So this is what it means. So now what can we do now in order to get beta now, so that we can be able to find a theta here? So in order for us to get beta based on this equation, in order for us to get beta, we need to look at, remember, angle of inclination is what? Come on guys, if you've seen the previous video, angle of inclination is the angle that the straight line makes with the x-axis. So now this one was the angle of inclination because it's making the x-axis here. So therefore even this one is the angle of inclination. So therefore, if this is the gradient, therefore it simply means, therefore we are going to say tan beta is going to be given by the gradient of line BC. So therefore the gradient of line BC, we know that is 5/2. So therefore tan beta, we are gonna go to our calculator and say second function tan 5/2. This should give us an angle, but remember, because now there's no negative here guys, there's no need to worry about that. We can just put it as it is, as a positive. Therefore let's go. Right, so now if we punch this in our calculator, what I'm getting on my side, I'm getting 62.198. That's what I'm getting. So therefore guys, if I have beta and then I have alpha, therefore it will be easy for me to calculate theta. So therefore we are just gonna come up here and say, okay, alpha plus theta plus beta. All right, what is alpha? It's 153.43, and then theta, we don't know what it is, and then beta, it's 68.198. Therefore take the one to the other side, and then we punch this into our calculator. We should arrive at an answer. Let me see what I'm getting here on my calculator. We should therefore arrive at an answer of 85.2. All right, and that's how you would deal with this question of 3.3. guys, don't let it confuse you on analytical geometry. The only thing that you need to think about is the angle of inclination, which is the angle that the straight line forms with the x-axis. If you know the definition, you can define it, then you shouldn't struggle with the going around it. So now let's go ahead and have a look at 3.4. all right, I'm just going to change the color here due to the request that was sent to me on the comment section. Somebody said if you answer in the next question, please change the color to make life easy for us to see. All right, I'm going to do exactly that. And then 3.4, they said find the equation of a straight line BC. All right, do we have a gradient of line BC? Yes, we do have a gradient of line BC. It is given by 5/2. Do we have any coordinate? Yes, we can choose any coordinate that we want. Therefore, in this case, I would like us to choose the coordinate that was given, which is coordinates of C, and is given by 3 and is to 4. Right, so therefore we can use this formula y minus y at C. It's equals to the gradient of the line, and then therefore x minus x of the coordinate that we have chosen. So it's going to be here x y minus 4. It's equals to the gradient of 5/2, which is the gradient of the line, minus 3. So therefore now we need to remove the bracket and then move forward to the other side. I'm gonna do that straight away because you guys are already in grade 12. You shouldn't struggle with this one. 5/2 times x will give us 5/2x, and then 5 times 3 will give us 15 divided by 2, and then we move the 4 to the other side. It will therefore change the sign. When you move it, this sign is going to become +4. So therefore, if we punch this into our calculator, we should get 5 over 2x, and therefore that fraction should give us negative 7 over 2. Great. And therefore this is the equation of the line BC. All right, moving right along, let's move on to 3.5. 3.5, let's change the color. Okay, 3.5 is to determine the area of they want us to determine the area of this equation. So therefore this is what we will do here. They want us to determine the area of triangle C. Let's see, triangle C. Where is E now? E is E there, and then what? And then F. Okay, so therefore I'm just gonna try to highlight it here so that you guys can see the angle they are referring to. They are referring to this angle here, or triangle rather. All right, so now what would we do here? Okay guys, you would remember that when you are dealing with an area, they like bringing these questions a lot. What you must have a triangle that is looking like that. What you would use, area, the formula of the area, if you check on a formula sheet, is given by half base times perpendicular height. So therefore what you would do, perpendicular height is given by this part here. All right, so if you know this distance from here to there, it should give you the perpendicular height, then you shouldn't have a problem. The base would therefore be this one. This one would be your base. So now let's come here on our let's have a look at the base. Our base here in this case would be EF, or FE rather, it doesn't matter, EF. So this part here is our base. Do you guys agree? Let me know what you think of the comment section below. And then the perpendicular height is from here. Now I'm just gonna do it with the dotted line here. Now this gives us the perpendicular height. All right, so guys, let's go ahead. Let's look at the coordinates of E. Can we get coordinates of E? Yes, we can get them because we already know the equation of this line. So therefore, looking at it, this would be our y-intercept. Therefore x is 0. What is our y-intercept here? In this case, it would be positive 11 over 2. Okay, great, we're looking good so far. And then the coordinates of E, we can get them as well because we do have the equation of line BC. This looks like it's our y-intercept, therefore this would be 0. Our y-intercept will therefore be negative 4 over 2. Makes sense, guys, right? So now let's go ahead. In this case, what we would do, we have to look at the distance or the base in this case. So now our base, which in this case would have to be the distance of EF in units. So what would you do in this case? So you are looking at this one where now from here negative doesn't matter, so you can easily add these two values here of the y. So you can simply say it's going to be 11. Okay, this doesn't look like 11 here, guys. 11 over 2 plus 7 over 2. So if you were to add that onto your calculator, you'll get a value of 9. All right, so the perpendicular height in this case, perpendicular height, guys, will simply be given by this distance here. Maybe I should look for a different color to illustrate this one, but I hope you guys can see. Let me see what I can do here, because I don't want you guys now to get to the point where now you can't see what I'm talking about. So now let's have a look at this one here. I'm gonna use okay, let me go back to a red color. So here, from here to here, this is your perpendicular height. So what is this distance here? Basically, you are just moving from here to there, to this vertex of C. So it does see, you can see that this is just from the y-axis moving to vertex C. This will give us 3 because the x value there is 3. The y value doesn't change, remains as 4. So now therefore, with this in mind, we can come here and look for that area of this triangle now. So now we can come here and say half is equals to base, which is 9, times the perpendicular height, which is 3. Therefore, our area for that triangle will be given by this. So therefore, if we were to punch this into our calculator, we will find that it's going to be 13.5 units, because they didn't tell us the units, but you need to show that you understand what you're doing. So therefore, we'll just refer to the units as units squared. All right. Thank you very much, guys. I think that's it on this question. Let me see you on the next upload, where we'll be doing question 4. Please make sure that you stay tuned and you watch the rest of the question paper. I will do my best. Let me know what you think, guys. If I'm not explaining properly or you don't get it, leave a comment. I will see you then. My name is Gaston Mapala.